Hello everyone. Today we are going to discuss about the elementary linear algebra exercises 1.2. I am Carla Joyce Puno from the BS Ed Mathematics. I am Carla Joyce Puno and I am assigned to answer the number 57 on the chapter 1 exercises 1.2 about the Gaussian elimination and Gauss-Jordan elimination. Let's solve it. Exercises 1.2 Number 57. Instruction: True or false? In the exercise number 57 and 58, determine whether each statement is true or false. If a statement is true, give a reason or cite an appropriate statement from the text. If a statement is false, provide an example that shows the statement is not true in all cases or cite an appropriate statement from the text. These are the given on the number 57. We have A, B, C, and D. First, letter A. 6 by 3 matrix has 6 rows. This is from the module Elementary Linear Algebra. It is shown here where is the row and the column on the matrix. The format of the matrix read as M by N, wherein M is the row and N is the column. These are the example of matrices. On the letter C, the number 1 is the M, which is the rows, and 4 is the column, which is the N. That's why the matrix has 1 row and 4 columns. On the letter D, 3 by 2, wherein 3 is the M, the rows, and 2 is the N, the columns. The matrix has 3 rows and 2 columns. Therefore, the given on the statement 6 by 3, the 6 is the M, which is the row, and the 3 is the N, which is the column. So we conclude that there are 6 rows and 3 columns on the matrix. So, the statement is true. 6 by 3 has 6 rows. Next, letter B. Every matrix is row equivalent to a matrix in row echelon form. The statement is true. Matrices are row equivalent if one is the product of another through a series of elementary row operations. As such, every matrix is row equivalent to a row echelon form matrix because every matrix has a row echelon form matrix resulting from an augmented matrix. In other words, any matrix can be changed to a row echelon form using successive elementary row operations. In this example, we can see the process of solving a system using the elementary row operations, wherein the come-up matrix is in the form of the row equivalent, and then the last matrix is in the row echelon form. In this picture, we can read the definition of the row echelon form of a matrix. Next, the letter C. If the row echelon form of the augmented matrix of a system of linear equation contains the row 1, 0, 0, 0, 0, then the original system is inconsistent. The given row 1, 0, 0, 0, the associated linear equation is 1 x sub 1 plus 0 x sub 2 plus 0 x sub 3 plus 0 x sub 4 equals 0. Then we can conclude that x sub 1 is equal to 0. Then substitute the 0 and we will get the 0 equals 0, which is consistent. In a row echelon form of an augmented matrix, this must be the first row. Then the last row of the matrix can be 0 equals 0. So the original system is consistent. This is the example of a system of linear equation to augmented matrix. Augmented matrix includes the constant in the equation. Therefore, the statement is false. And the last one is the letter D. A homogeneous system of 4 linear equations in 6 variables has an infinite number of solutions. Based on the theorem 1.1, the number of solutions of a homogeneous system. Every homogeneous system of linear equations is consistent. Moreover, if the system has fewer equations than variables, then it must have an infinite number of solutions. In this example of homogeneous system of linear equation, it has 2 equations and 3 variables. There are more variables than the equations. Therefore, we conclude that it has an infinite number of solutions. Therefore, the answer to the given statement is true, since it is stated that there are 4 linear equations in 6 variables. The system has fewer equations than variables, then it has an infinite number of solutions. That's all. Thank you. Again, I'm Carla Joyce Puno from the BSED Mathematics.